Okay, this video is meant for my Algebra 2 students, and we do have a quiz coming up on Tuesday covering sections 6.1 through 6.3, so this is your quiz review. We'll start with some exponent problems here. So it says evaluate the expression and state the properties. Now, you don't have to state the properties on the test or quiz, but I think it's a good idea as you're practicing. So here we go. 2 to the negative third times 2 to the negative second. This is a product of powers. Product of powers. And you see you have multiplication going on between two 2's, each of them having an exponent. So that means you add the exponents. So this becomes 2, and when you add negative 3 and negative 2, you get negative 5. So product of powers means you add the exponents. And now I see a negative exponent. A negative exponent means you take the reciprocal, REC, reciprocal. So this 2, there is no fraction, so the 2 is assumed to be in the numerator. So this 2 goes to the bottom, the denominator. And when it moves, its exponent becomes positive to the fifth, positive 5. And since there's nothing on top, I put a 1. And then you just have to multiply that in your calculator. 2 to the 5th. It's going to be 1 over, and 2 to the 5th is 32. So there's how you evaluate this problem here. So again, it's not a bad idea to write down those rules. Okay, here's our next two problems. We're going to simplify these, and now these involve some variables and some numbers. So if I look here, this is a power of a product. Power of a product. This negative 4 needs to be distributed to each part of the product. So when you have a power of a product, it's like distribution. So the 5 is part of this multiplication. The 5 gets the negative 4. The x squared, and notice I'm going to put that in parentheses, gets the negative 4. And the y to the negative third, parentheses, gets the negative 4. Okay, now I'm going to hold off on this 5 to the negative fourth. I'm going to look at these two situations with these parentheses. These are power of a power situations. And when you have a power of a power, you multiply. So the 5 to the negative fourth stays the same. This becomes x to the, and 2 times negative 4 is negative 8. This becomes y to the negative 3 times negative 4 is positive 12. Now, I see some negative exponents. And again, as we talked about, negative exponent means reciprocal. So they move. So I'm going to scroll this down. So this 5 is going to go in the denominator, and its exponent becomes positive. This x is going to go to a denominator, and its 8 becomes positive. This y, no negative exponent, stays on top. And now the final thing you have to do is to do 5 to the 4th. So we have y to the 12th over 5 to the 4th, and your calculator is 625. 625 x to the 8th. And there's your fraction answer. Okay, so that's that one. Alright, scroll it up to B now. B. We have this fraction here. Now, since we already have a fraction, I know there's x's and y's on top and bottom, but I want the negative exponents gone. So negative exponents mean you do the reciprocal, which means it moves to the other part. So the x squared is positive exponent, stays on top. The y to the negative second has a negative exponent, goes to the bottom, and when it goes to the bottom, the negative 2 becomes a positive 2. The x to the negative first on the bottom moves to the top, and its exponent becomes positive 1. And this y on the bottom, positive exponent, stays the same, and that positive exponent is a 1. And now notice, you don't have x and y on top and bottom, you have x's on top, y's on bottom. This is now the product of powers, where you add the exponents, because you have x's on top, 2 plus 1 is 3, there's 3 x's on top, y's on bottom, 2 plus 1 is 3 y's on bottom, and there's that, y to the third on the bottom. And there you go. So two great examples of properties of exponents with variables. Okay, problem 3 here says, tell whether the function is a polynomial function or not. So this is section 2. And if you look at this function, it says f of x equals x cubed plus 5 over x squared plus x. And this is not a polynomial function. And the reason that it is not a polynomial function is because of the x in the bottom. You can't have the variable in the bottom. That's not allowed. Okay? This is actually 5 over x squared is actually 5x to the negative 2. They're actually the same thing, and that's a negative exponent. You can have a negative exponent. Okay? So that's the idea. So this is not a polynomial function. Okay, next problem here says classify the polynomial. So we're going to write the polynomial in standard form. Then we're going to state its degree. We're not going to worry about the type. You don't have to do that on the test. So we're not going to worry about the type. So state the degree and the leading coefficient. Alright, so standard form is highest power to lowest power. So f of x equals highest power is x to the third. There's a negative sign in front of it, so we put that. Okay. Next highest power is x squared. It's positive because there's no symbol. Positive x squared. Got that. The next highest power of x is x. There's a plus 4 in front of it. Got that. And then the minus 7. Standard form. The degree is the first exponent you see in standard form. That is this 3. The leading coefficient is the first coefficient, or the first big number you see. Well, I see this negative sign. That means there's a negative 1 there. And there's your standard form with your degree and leading coefficient. Okay, here's our fifth problem here. We're going to graph the polynomial function using this domain. Okay, and let me pull up a graph real fast. Okay, so there we go. So first thing I want to do, though, is I want to do the end behavior. So I want to do the right and left side. Now, first, is our function in standard form? Highest power, 4. Next highest power is x, the first, and then the number. Yes, it's in standard form. So, the right side and the left side. This is the end behavior. To identify the right side, we look at the leading coefficient. And the leading coefficient in this case is that negative 1. That is a negative number. That means my right arm is down. So the right side is going down. Now, I look at the degree. The degree is the first exponent I see. That's a 4. That is an even number. Even Steven, if the right side goes down, the left side has to go down. And there's your end behavior. So when we graph this, we should expect that we're going to go down and down on the left and right side. And now we're going to create the table. I'm going to create the table in green, and then I'll fill it in orange. So here's my x's from negative 3, negative 2, negative 1, 0, 1, 2, 3. And this table will be provided for you on the test. I'm going to show the substitution for a couple of them. And then here's my y, or my f of x. So the first one here, if I fill it in, would be negative 3 to the fourth plus negative 3 plus 3. And I'm going to go through this slowly with you in the calculator, so hopefully you have your calculator at home with you. Okay? Remember, there's a way to do shortcuts, right? So we're going to go negative parentheses negative 3 to the fourth plus parentheses negative 3 plus 3. Okay, I got it typed in right. I press enter, and I get negative 81. So now I do the same thing. I press the up arrow or second enter if I have a graphing calculator, and I'm going to change all of those negative 3's into negative 2's. Negative 2, negative 2. And when I press enter, I get negative 15 this time. And I'll do the same thing. Get back into that line, change all my negative 2's into negative 1's. I get 1 this time. Okay, get it back in there. I'm going to delete the negative sign now and change the 1 to a 0. Delete the negative sign, change the 1 into a 0. I get 3. Then I'll change the 0's into 1's. And I'll get 3 again. Then I'll change the 1's into 2's. Negative 11. And I'll change the 2's into 3's. Negative 75. Okay, so there is the values, and again, I'll go ahead and throw that last one in there. Negative 3 to the fourth plus 3 plus 3. Okay, that would be the substitution for the last one. So on my graph here, I'll use blue. And first of all, I just want to label the x negative 1, negative 2, negative 3, and 1, 2, 3. Okay, so that's all I need because those are my x values. So now, in blue, when x is negative 3, y is negative 81. So x is negative 3, go way down here, y is negative 81. When x is negative 2, y is negative 15, right around there. When x is negative 1, y is 1, just a little bit above that x-axis. When x is 0, y is 3, just a little bit more above. When x is 1, y is 3, a little bit, or the same level as you just were at. When x is 2, y is negative 11, just below where negative 15 is. And when x is 3, y is negative 75, way down here. And you can see if you connect the dots, I'll try my best with a smooth curve. And it goes down. Looks something like that. Finishes down, down, just like you said. And there's your graph. Okay? So, as long as you have a calculator, graphing should be no trouble at all. Make sure you worry about that in behavior first. Okay, I have a couple simplifying ones here, adding and subtracting polynomials. So here we go. We have these two polynomials, and this symbol means subtraction. And when you are subtracting, think of this as a negative 1 and distribute it. So the first parenthesis remains the same. So I use the blue. So we have the first parenthesis is 2x cubed minus 4x minus 1. But then that second parenthesis, everything becomes opposite. The positive x cubed becomes negative x cubed. The positive 5x becomes negative 5x. The positive 7 becomes negative 7. And now we combine our like terms. The highest power, x to the third. 2 of them here, negative 1 here. 2 minus 1 is 1. You can write the 1 or don't have to. X to the third. Cross them off. Negative 4x, negative 5x. 4 negatives, 5 negatives, that's 9 negatives. Negative 9x. There are no x squares, notice, so we just go right to the next highest power, which is the x. Cross those off. Negative 1 and negative 7, the last numbers. That would be 8 negatives. Gone, gone. And when all your terms are gone, you are simplified. Subtraction. Distribute the negative. Okay, problem B here, same kind of idea, alright, except now, if you notice, we have more to distribute. We have a 2 in front of the first parenthesis and a positive x in front of the second one. So again, this is overall addition, so I'll put add there. But now we have to distribute. And we have multiple things to distribute. Here, the 2 goes to everything in the first parenthesis, the positive x goes to everything in the second parenthesis. So, 2 times 3x cubed is 6x cubed. 2 times negative x squared is negative 2x squared. 2 times positive 5x is positive 10x. That's the first parenthesis. Second parenthesis, positive x times negative 4x squared. Positive times the negative is a negative 4. And now the x and x squared, there's one x here and two x's there. That's 3 x's, x cubed. Positive x times positive x is positive. X times x is x squared. And then positive x times negative 7 is negative 7. And then the x just comes. We are all distributed now. Combine your like terms. 6x cubes minus 4x cubed. 6 minus 4 is 2x cubes. The x cubes cancel. Negative 2x squared, positive x squared, that's negative 2 plus 1, that is still negative 1x squareds. They go away. And then the x's. Positive 10, negative 7, 10 minus 7 is positive 3x. And that is simplified because all our terms are away. So notice the only multiplication I do is when I distribute. I am not multiplying the two parentheses together. I'm just distributing the number in front of the parenthesis to what's inside the parenthesis. Good. Last problem coming. All right, here we go. So you have a word problem here. So it says, let T be the number of new truck sales, and it's in thousands. So remember, we talked about this class, in thousands means multiplied by 1,000 in the end. So we'll do that later. C is the number of new cars, again in thousands. From 2000 to 2005, T and C can be modeled by the following equations, where T is the number of years since 2000. Keep that in mind. So here's our two equations. Find a new model D. So this is part A. Find a new model D by subtracting C from T. D equals, we subtract C from T. That means we start with T and subtract C. So what does this mean in my problem? Well, I'm going to go to the next line so I have enough room. Okay? So what does this equal? Well, T stays the same. Negative 20.9 T to the fourth plus 186 T cubed. It's not going to matter. I'm going to roll over anyway. Minus 453 T squared plus 372 T plus 8,955. Okay, that's T. And now if we're going to subtract C, we're going to take all of the terms in C and make them opposite. So I'll do it up here. That becomes negative. This becomes positive. That becomes negative. This becomes positive. That becomes negative. T minus C. Everything's negative. So now when I put that down here, and I'm going to roll over, that's going to be a negative 3.58 T to the fourth, a positive 13.2 T cubed, a negative 8.33 T squared, a positive 394 T, and a negative 8846. And we will combine those with our calculator. So I'll do it with you. So we have negative 20.9 minus 3.58. That's negative 24.48. And that's T to the fourth. 186 plus 13.2 gives us 199.2, and that's T to the third. And that's positive. Negative 453 minus 8.33 gives us negative 461, so minus 461.33, and that's T squared. A 372 plus a 394 gives us a 766, and that's T positive. And then an 8955 minus an 8846 gives us a 109, and that's positive. And there's your D model. And what does that mean? That just means, how many more trucks there were sold than cars, right there. Okay, and we'll kind of answer that in the second part. So then I'm going to use D in 41 in part B to evaluate. I'll use a different color. So in part B, it says, okay, now evaluate this for the year 2003. Well, the year 2003 is how many years since 2000? Well, it's 3 years. There's my T value. T is 3. And that's what we plug into this big long formula. D equals negative 24.48 times 3 to the fourth plus 199.2 times 3 cubed. Jeez, oh man. Minus 461.33 times 3 squared plus 766 times 3 plus 109. And I'm actually going to scroll to the right and type all that in. Let me type it in first, and then I'll scroll to the right, because we have to do something. Negative 24.48 times 3 raised to the fourth plus 199.2 times 3 raised to the third minus 461.33 times 3 squared plus 766 times 3 plus 109. And I get this number right here, and I'm going to put it right to the right of this. 1650.55. And hopefully that's what you got. I did not make a mistake, I hope. Looks good to me. That is how many more trucks than cars were sold. But this number is not correct yet, because if you remember from the beginning, this is in thousands. Times it by 1,000. Times it by 1,000. And what's that going to do? Just move the decimal 3 places to the right. 1,650,550. And that is 1,650,550. And that would be more trucks than cars. And that's what this answer means. There are 1,650,550 more trucks than cars. Okay, so thanks for watching. Hopefully you follow along this video and you feel very prepared for the quiz on Tuesday. We'll see you then. Have a great weekend.